Guys, it's finally time. We're going to work on the 3D printer, so get excited. What is up, everybody? My name is Will. Welcome back to the channel. So as I stated, today we're going to work on my 3D printer. Finally, it's only been sitting here for a year? I don't know, it's been a while. I broke some things, so let's get into it and talk about it. So before we get into what's in this fun little box, which is all of the electronics that I now need, as far as I know, to make this thing actually work, we're going to investigate what actually happened to it, because like I said, I broke some things and may or may not have almost started a fire. I don't know, let's find out. Alright, so this is my Delta style rep wrap, currently called Athena. So when I built this printer a few years back, it was part of a class that I took all on about 3D printing. So we went through like how to put this one together, what it takes to run it, the software that was on it, you know, all of that fun stuff. So this one was about $500, I think, but that was back in late 15, early 2016. So it's since been a little outdated. So if you guys are curious, so RepRap essentially is a 3D printer that can be made using another 3D printer. So if you look, and I'll show you guys as we're going along, all of the corner pieces, the carriages, even the hot end extruder piece are all 3D printed. So basically what you can do is take the model of whatever piece you may have broken to somebody else who has a 3D printer. They can print you a new piece, you bolt it all back in, and you're ready to go. Mine was made to be cheap, so that's why it's got a wood frame. I've never really been a huge fan of that. At some point, once I get this one going again, I'm going to redo it. I'm going to find some designs for a Delta 3D printer that can use that extruded aluminum, commonly known as a T-slot. You guys can find it on McMaster, relatively cheap. And then that should give me a little bit more stability, a little bit more stiffness, rather than this wooden frame, which has worked, but not really my thing. So we're gonna do that at some point. I don't know when. I keep talking about that, but I just haven't done it because this printer's been broken for so long. So anyways, we're going to start taking this one apart and investigate what happened and what I may or may not have done to it. So me and this printer have had an interesting relationship. We have an interesting background. I'm not really sure what you want to call it. But anyways, when I first built this 3D printer, it was running Repetier software, which is essentially just a 3D printer controlling software that was made by a larger company. It was something that was easy to get going on here, and that we were given, you know, from the beginning of the class. Later on, as we continued on through the class, the PhD student that was helping the professor showed us a open source, I guess you could call it, software that he had developed, which allowed you to do a bunch of cool things. Like one of the things you could do with this printer was hook up an Xbox 360 controller to it and kind of control where the hot end moved. I believe that was so you could replace the hot end with a camera and do some like stuff similar to a microscope. I never really got into that, but it was kind of a cool feature that it had. But anyways, when I went to install that software onto this printer as part of the class, it didn't quite install right. Like, it just didn't seem like it quite operated right, and I wasn't a huge fan of it, but I could never figure out how to switch back to Repetier, which I actually really liked. So anyways, as I was going through using it, you know, off and on for different class projects, different things, something happened where all of a sudden this printer had short-term memory loss, which sounds really weird, but trust me, it's a thing. So what would happen is I would go to upload a large print to the printer, and it would essentially get like halfway through uploading and then just crash. And I couldn't really control it, couldn't see if the print actually got fully uploaded to the printer, you know, that kind of fun stuff. So what actually ended up happening is I had a couple of those prints where it'd be like, yeah, you know, it uploaded, but it wouldn't actually be fully uploaded. So I'd hit go on the print, get like a half or maybe even a third of the way through, and then the printer would just stop. And so then I'd have to start all over. I'd have to reslice my model, have to re-upload it, all that fun stuff. And I just have to make sure that when I was uploading that model the second time that the printer didn't go to sleep or didn't go, idle, because otherwise the software would crash, and there's a whole thing. But I learned to live with it. I kind of fought through it, figured it out, and then it just decided to stop working one day, and I got frustrated with it because I was uploading some prints that would take a long time. And part of that is due to I like to run a really thin layer, which I'll explain that here in a second if I find a good print. We'll use this one. So this print is a sample corner piece that I printed off that I was thinking about using. Not sure if I'll use this one or if I'll just design my own. But anyways, the layers, and I hope you guys can see this, are each layer of plastic that's on here. So a 3D printer, prints just like a normal Xerox printer. You tell it what to print, and then it'll just start building it up in layers. And so I like to run a really thin layer, so then you get a high amount of resolution out of your prints. And then it also requires that you have a really big file to run the G code that's required to run the printer. And so then that would cause my printer to not upload correctly and crash, and we went back and forth with it, or me and the printer. I kind of treat it like a person, argue with it, that's kind of a fun thing. Anyways, so one day it just decided to stop working, and so I was like, whatever, I just left it alone, assumed that one of my control boards had died. There's actually two under this printer, and we'll go into that in a little bit later when I flip it over and we start to look at stuff. So anyway, so I left it alone, came back to it a few months later, and it started working. I was like, cool, this is awesome, it's figured its life out for whatever reason. And then I started to hear the infamous zips and zaps of electricity shorting out. And so then this fun thing happened. I can't actually unhook this 12-volt cord from its outlet on the printer, because I may or may not have welded them together. I'm not really sure. And all I know is it just won't come out. So I'll have to replace that at some point, which will be super fun. But anyways, to save my house from burning down and or my whole printer from catching on fire, I just unplugged it and left it until today, where we start to investigate what the deal is, start to take it apart, figure out how I'm going to connect that new control board, and do all that fun stuff. So yeah, so first thing I'm going to do is take the build plate off, because I don't want to break this one. This is actually a really nice one. Yes, I've broken a few. When we started building these printers, they said to print on a mirror, like a 10-inch round mirror. So I've bought a few cheap mirrors and broken them just because prints would stick, and then I'd pry on them, and yeah, you guys could probably figure that out. This build plate is actually borosite glass, which is supposed to release prints and hold heat better and that kind of thing. So really don't want to break this one, so we'll start by taking that off. Well, good news is everything looks relatively okay under here. I don't see anything that looks too crazy or too melted, but that doesn't really mean anything with electrical components. It could still be bad. So anyways, this is what the underside of my printer, my 3D printer, looks like. So as you can see, we've got 3 stepper motors, and those control the carriages as they go up and down, and they're all coded in to be, a certain step up a certain way, step down a certain way. Then we've got the control boards under here. And so what we've got is, to run a lot of the main processing, we've got a BeagleBone Black, which I don't know which version it is yet, I've forgotten. But essentially what that is, for those of you that don't know, is that is an open source version of an Arduino, essentially. I'm actually going to see if that's still good, because if it is, I can probably find something to do with it. Hopefully, but we'll see. Then next to it is a Melzi board. What a Melzi board is it allows you to control all the stepper motors, the extruder motor, and the hot end. And so there are better ways to do this, or I should say more elegant ways to do this, rather than having the BeagleBone go through the secondary board into the Melzi board. For instance, you could get an Arduino Ramps board, which is essentially this board, but then you put another board on top of it, and that's what controls everything. It's a smaller package, looks a little nicer. But this way, I guess, I've read, is actually not a bad way to do it either. We'll go into the board that I'm planning on putting in this, and it'll help simplify a lot of this wiring later. But for now, we're going to get everything ripped out of there, get all my wiring marked so I know where it goes, what it is, and then we'll start assessing what each board looks like and how savable or usable it is for later. So you guys are probably going to see me dig around in this box a lot. Essentially what it is a pile of tools and a few extra pieces that I was given during the class when I was building this printer. You can disregard what the box actually says, because we were just told to bring a box of certain sizes to hold everything. I should really get a small toolbox or some sort of better tool storage than what I've got, so that might be on the list of things to do at some point. Not really sure when yet. We'll worry about that later, though. That's a future me problem. This time you would have to burn me down. I ain't falling this time, you would have to burn me down. Reaching up from the ground, trying to not think about you, whilst you're in my mind, screaming loud. Still so lost, scared to find reasons to not be without you. Wish I could have my head in the clouds. You came out searching for a reason, came out looking to throw me around, but I'll be holding on forever. I ain't falling this time, you would have to burn me down. I crumble deep into the feeling that you leave me to drown. Yeah, I'm still holding up together. I ain't falling this time, you would have to burn me down. So before I decide to just start ripping all the wires out, decide to be smart and make a diagram so I know what each one of these screws is, and so I know what each one of these wires is and where they go. Try to figure out what they do, just so I don't mix them up and end up shorting out my new control board. So basically what I did, and you're gonna have to ignore my bad handwriting and bad drawing, but I went and drew out each one of these headers, labeled it like it's labeled on the board, and then labeled each wire going into it. Now I may end up redrawing this because it does kind of bother me that it looks a little ugly, but if it works, it's fine. So anyways, so we got that, and we've got all of our wires marked accordingly, so I know where everything goes, sort of. And yes, for those of you that are bothered by my wiring job, I will clean it up and make it look a little bit nicer, but that will be later once we get it running.
searching for a reason. Came out looking to throw me around, but I'll be holding on forever. You won't bring me
Alright guys, so now I have the Melzy board out, and looking at it initially, everything looks pretty good, other than like somebody, when they made it, they didn't line these up, which kind of bothers me, but you know, whatevs. So anyways, I'll get this marked down on my wiring diagram here in a second, so I kind of have an idea of where everything goes when I go to wire up the new board. One fun thing I did find is that the leads from my hot end do seem to have gotten a little warm and actually melted the sheathing on the outside of the wiring. To be fair, this is just speaker wire, so take it for what it is. At some point I should pull all the wiring out of this and redo it. I've never really liked the way the class taught us to do it, or the wiring that they gave us, so at some point that may be another video where I go buy a bunch of wiring and just redo this. For instance, like they just told us to spin all these wires together. Don't really like that, so what I may end up doing is getting some looming, some of that loom stuff for like automotive underhood wiring, or just wiring in general, and do that. Or I may just get some nice wires and just run it all new and, you know, make it look really nice. So anyways, I'm gonna get this marked down quick. Guys, so we've got the boards out of the way, wiring kind of pulled back so I can at least see what we're doing. So now I'm gonna unbox the new control board and get that all laid out so you guys can see it, and so I can actually take some time and look at it more fully than I already have. For those of you that don't know what you're looking at, which I didn't either for a little while, this is a clone of the Duet 3D 2 Wi-Fi, which for those of you that don't really care about the name, the Duet 2 is an all-in-one 3D printer control board that also has a Wi-Fi antenna on it, which is going to make life a little bit easier and probably just make it a little bit more fun to mess with. So what this board allows is that each of the stepper motors and all of the controls are connected into one board, and that's it. Everything's done here. It's a much smaller, kind of nicer looking package than the BeagleBone and the Melzy board that were previously in this printer. The other thing that the Duet allows for is this fun little guy, which is I think it's color, not really sure yet, we'll find out, is a touch screen. So you can control the printer a little bit better. You can watch some stuff a little bit differently. You know, make it a little bit more interesting to use than what was previously here. This kit also includes a connector wire for the screen, another little board for the screen that I'm not quite sure what it does, but it goes in there. And then it also includes heat sinks for the chips and pins for all the wires, which I think it looks a little bit nicer because you can pin all of the wires and they go into each of these plugs, and it just looks a little bit cleaner than the screw and headers that were on the Millsy board, at least in my opinion. Whether that's true or not, we'll find out. So yeah, so now we're gonna figure out how to mount this board up, or at least partially mount it, so I can start figuring out where all the wires go, and yeah, do some of that fun stuff. Alright guys, so I got the Duet kind of mounted where I want it, or at least I thought that's where I wanted it. The more I look at it, the more I dislike the old mounting strategy from the Beagle and Millsy boards, just because they're, let's see if you guys can see that, like an ABS plastic or PLA plastic, and they warped due to what I can only assume heat under the bottom side of my printer. So to prevent that, I may or may not end up cutting some more holes and hooking up a fan and making that more ventilated, or I'll probably end up pulling the board out, maybe look around the internet to see if there's a better mounting strategy out there that I can just pick up and mount to my printer. I'm also going to need to change my wiring strategy, just because from the old boards, I'm sure as you guys saw, some of the wires are really short. So that's going to be something I'm going to have to deal with. I'll have to rewire and deal with that a little bit. But anyways, I'm really happy with how the board looks and some of that kind of stuff, and where this printer is going to end up being, or I should say end up going as a result of the new board. So anyways, that's going to be it for today, guys. If you enjoyed this video, don't forget to like and subscribe, so you can be up to date when part 2 and or part 3, 4, however many parts of this video series there's going to be. So anyways, thank you guys for stopping by. Hope you have a good one. I'll see you later. Bye.